The project title is Eplq, that is Efficient Privacy Preserving Location Based Query over Outsourced Encrypted Data. In this, the existing system is efficient challenges still remain the design of privacy preserving LBS, and new challenges arises particularly due to data outsourcing. In recent years, there is a growing trend of outsourcing data, including LBS data, because of its financial and operational benefits. Lying at the intersection of mobile computing and cloud computing, designing privacy preserving outsourced spatial range query faces of challenges. Existing solutions cannot address all the above challenges. The LBS provider is not willing to disclose the valuable LBS data to the cloud. The cybertext only attack, the attacker is able to observe the cybertexts of POI's location and queries about does not know the plain text. Every cloud has this ability. This is a weak attack model. Disadvantages of this method are querying encrypted LBS data without privacy breach is a big challenge. High computational cost and or storage cost at user's side. The techniques used to realize privacy preserving query usually increase search latency. The proposed system. At first, we propose a novel predicate only encryption scheme. We propose novel predict only encryption scheme for inner product range named IPRE, which allows testing whether the inner product of two vectors is within a given range without disclosing the vectors. Second is we propose Eplq, an efficient solution for privacy preserving spatial range query. In particular, we show that the whether POI matches as partial range query or not can be tested by examining whether the inner product of two vectors is in a given range. Then the third one is our technique can be used for more kinds of privacy reserving queries over outsourced data. In the spatial range query discussed in the work, we consider Euclidean distance, which is widely used in partial databases. We propose IPRE, which allows testing whether the inner product of two vectors is within a given range without disclosing the vectors. Our techniques can be used for more kinds of privacy preserving queries or outsourced data. Weighted Euclidean distance is used to measure the dissimilarity in many kind of data, while great circle distance is the distance of 2 points on the surface of a sphere. Security analysis shows that Eplq is secure under known example sample attacks and cybertext only attacks. Advantages of the proposed system are our technique have potential uses in other kinds of privacy preserving queries. Cost will be less compared to the existing system. The cloud can observe both queries from LBS users and encrypted LBS data from the LBS provider, which could be an advantage to learn user locations. Our solution also has advantages over the solutions resilient to such attacks. Future enhancements. Two potential usages are privacy preserving similarity query and long spatial range query. In the future, we will design solutions for these scenarios and identify more usages. We consider cybertext only and non-sample attacks, which do not require attackers with very strong abilities. We will leave the attacks requiring very strong abilities for future study. Alternate titles for this is public key encryption for preserving location based on query over encrypted cloud data. Another one is public key encryption with query search and its extension to a multi-user system. The final one is secure ranked query search over encrypted cloud data. System requirements or the software requirements or front end is Visual Studio.NET 2010, code behind C#.NET. Backend is SQL Server 2008. Operating system needed is Windows 7. Hardware requirements or hard disk needed is 40 GB, RAM 512 MB, processor is Pentium 4. Monitor needed 17 inches color monitor. Thank you.